to remember about Boolean algebra, besides the rules that you see there, of course, you need to remember that whenever you double negate something, you'll get back the original value, right? So if you double negate Q, you'll get back Q. Commutative means that you can easily switch them around. So you can switch P or Q and get Q or P. Right? It doesn't matter, right? You can always switch them around. Right, good. I want to go over we should know the associative law. Associative law means I can group them differently. So, and you'll get the same answer. I could group up P and Q, P or Q and work it out, or I could group up Q and R and work it out with, again, P. But the one I want you to remember is that I want to remember the distributive law. So the distributive law kind of shows you how to expand things out. So you have P or you multiply that by Q and then you multiply it by R. And you will get those two parts there. And then in the middle is the AND. All right? I'll show you again, right? So it's P and you're multiplying P and Q. You're multiplying P and R. And then all goes in the middle. So it's just like expanding something out, right? That's the distributive law. Sorry. That's the distributive law there. Right? Just like expanding it out. Next, underneath that is De Morgan's law. De Morgan's law is like multiplying by a negation. So when you negate P, you'll get the negation of P. When you negate a or, you'll get and. When you negate Q, you will get the negation of Q. And that's it. All right? You have to remember the last two underneath, the absorptive law and the negation laws. Okay? That's just to remember. Right? This law is particularly useful. Right? We have to remember it, right? So I said I don't really have much, but let's practice a few, right? It had one in the past papers last week. What was the year again? But the year? Nice month. About the year? Nice. Let's try this one. So let's say we had to prove negation of P or Q and P or Q is equivalent to P or Q. Right? We had to find a way to show that. We had to take our time and break down every single thing. Ready? So we start with the left hand side. Right? So let's see what we have first. So the first thing I'm going to do is apply De Morgan's law to this part here. So I'll end up with negation of P, negation of P and the negation of Q, right? And P over Q, right? That's the first law. That's the Morgan's law there, right? Then we need to find a way to kind of bring things up a little bit, right? Okay, so watch this here. I'm going to use the distributive law. So I'm going to take this as one thing, and I'm going to expand with P and then with Q. So I'll end up with the negation of P and the negation of Q, right? All of that and P. Then the negation of P and the negation of Q and the Q. This is one part, this is the next part, and then O in the middle. You follow that? What you can see. So I treat this whole thing here as one, right? Multiply that by P and then by Q, and O in the middle. That makes sense? Well, okay there, right? Right now, we're going to simplify inside each bracket. So I'm going to simplify inside each bracket, right? So now, inside the bracket here, I'm going to get the negation of P and P and the negation of Q. I just put them together. And here, I'm going to get the negation of P and the negation of Q and Q. Right? Check back your laws, but the negation of P and P, that should be false. Right? That should be false, right? So the negation of P and P, that will be false, and the negation of Q. Or negation of P and false. Right? This here will be false again. Now, false for anything. Will I write the wrong thing here? Right? Going back to the top, it may have been just false. Right? I feel like I wrote down the wrong thing on top. Anyway, false and anything, that should be false. False and anything is false, so we end up with false or false to be false. All right, I feel I'll put something up with that exam. Right, I like that one. I'll try this next one. feel I'll leave out a piece when I write it down. I'm gonna write down something short, right? But let's try this one instead. Right? I feel I write something down wrong on that one. There wasn't really a proof. I just tried to make it equal to something. Let's try this one instead. P and the negation of P or Q. We could use distributive law and expand it out. P and the negation of P, or P and the negation of Q. P and the negation of P, that'll be false, false or anything, right? False or anything, anything. So the answer is P and Q, right? So that's QE. Right, copy down. Let's try the next one. Are you okay with that one? Down, move it a little better. You done? You okay with that one there? Go again. Try this one here. I only giving you ones that definitely have answers, right? Yeah.
Yeah, die Arbeitszeiten warten.
Huh? Okay. Yeah, yeah. I want to know what they found like. We can go on, but we have that. What about this sort of like the way in doing on solid? How let's say it's triggered my house bill. Change by that. So yeah, yeah. About this one, I call you access to number. Tomorrow, yes, we go. What about the fund? I think about that, but it's. What's the other thing? Right, so try that there. Hold on, before you start, to make sure I write it down properly. P and the negation of P or Q all in brackets, or Q is equivalent to Q. Try that. If you get it, message QED. Everybody, please. Finally get to just message QED, right? Anymore? Only have two. All right, let's see. Right, get more people in. So we're going to take a look at the expansion. I'm going to use distributive law first. Right, so I'm focusing inside the bracket. I'll get P and the negation of P, or P and the negation of P. And then we know that P shall be false. Right, this is false, right? And then we'll group these two together. We know false or anything. Right here. We know false or anything is well, I feel like I write something bad then. P and the negation of P, or P and the negation of oh sorry, I'll leave all the Q on the outside. Right? Now false or anything. Right, just now. This year I made a mistake here because I already practiced bad. Right. False. False or anything. Right. Right, so quickly brackets here, right? And now I can use the absorptive law and get Q. Right? That's QE. Right? I already brackets wrong. So the first thing I did distributive and I expanded it out. And then I said that P and the negation of P, that's false or anything. There's anything here, right? False or anything is anything. And then if you look at this law here, that's the absorptive law. So you will get Q as the answer. You're okay with that? Right, let's check out. Most people got it, right? Nice. Yeah. Make a note. Let's do one more, and then I want to take a look at the I really can't remember what year it was now, right? But let's do one more, and then let's try to do the linear programming, right? That's straight from C-sec, but we'll do a couple of and look at the worded part, look at the worded parts. Copy down, let's go again. Try this one here. Hold on, we'll start with that here. Negation of P or negation of Q or negation of P and negation of right here. Try it now. If we get QED message. Right, message Q, we haven't seen one so far. That is most likely Jesse. Chiran, I'm gonna get yours, Damian, Kiran, hurry up. All right. Time up. Any more? TN2. Let's go with it, right? I'm gonna take my time with it, right? So that'll be a little problem. So inside here will be negation of P and Q. Or negation of P and the negation of Q. So what you want to do here now is try to use distributive law and expand it out. So you'll get negation of P and Q, or negation of P, that's one. And negation of P and Q, or negation of Q. Right? When we expand this here, we'll get negation of P. And just switching them around, right? Or negation of P and Q. So I just switching those two around, and same thing here. Negation of Q or negation of P and Q. And then we will begin the process, right? Right? Negation of Q or negation of P. And negation of Q or Q. Right? Like, so we get negation of P. Right? I have the right negation there, right? All right. Negation of P or the negation of P. I like it kind of weird. Anyway, but if two of them are the same, well, we can just use absorptive law there. Do you recognize that? I can just use absorptive law here. And here I should get negation of P. Right? That's just by using the absorptive law. right? So that'll be negation of P. On the next side, I have to expand it. And here, I'll get negation of Q for the negation of P. And this here will always be you know why I feel like over here something wrong with this thing. Negation of P or Q, sorry, Q or that will always be true. True and anything is anything. Right? And then if I switch it around here, I can use the absorptive law and I will get the negation of P as my answer. Anybody try something different? Yeah? Try something different. Take a pick and seminar. Right, but I end up just using the absorptive law later on. Copy it up and head up linear programming. On, dot cross, okay. That's not algebra, but I'll check it out. Looking good. Looking way shorter and good. All right, copy it up. Let's go to let's try out the I'm gonna run through something quickly. Right? Head of linear programming, right? right? So if you remember your linear programming, right? So in your linear programming, what you have to remember is your Form 5 stuff, right? So remember, we will obtain a set of inequalities, right? And then these inequalities, right, we'll go through the definitions in a little while. These inequalities have their particular constraints, right? And then based on the inequalities, we draw the line. So for example, if a line looks like this, that's a line. Remember, that's not an inequality. It's a line. If the inequality says more than, we shade or we draw arrows above it. So by showing the arrows, we show the inequality region. If it were less than, it's generally below the line. Right? With a few exceptions, of course. But generally, that's the way it works. Above the line more than, below the line less than. You draw the line first, then the inequality. And what you do is, let's say you have a next one here, and you have to shade below the line, and you have the next one here, and you shade above the line. Now, you have three inequalities, right? And these three inequalities are satisfied by 1, 2, 3. This region here is a common region, right? And these 3 points satisfy these 3 inequalities. And then we take these 3 points and we plug them into something called the objective function, right? So these inequalities here, we call it the constraints. If you check the little I think I spelled that out. Right? If you check it, the little handout I send you, give you some definitions, right? And then we plug in these and we get the objective function, plug it into the objective function, and we determine if it minimizes or if it maximizes. That's it, right? The problem now is to identify the objective function, which generally easier, and then use that to come up with the constraints, right? Use that to come up with the constraints. All right, so let's take a look at these little things here. Ready? Carry on, make it good. Don't need graph paper, eh? I'm not doing this. I'm not doing this if you all do have graph paper and you're drawing the graph, huh? We have to do at least one today. Someone will do like to do nothing, but you do no graph and thing. Right? So basically, constraints set up all the inequalities, right? Set up the inequalities gathered from the information. The objective function is the function we're trying to optimize. Optimize means maximize or minimize. And here you have And here you have the little things to remember. So like if you see the word less than or fewer than, or at most, you know what symbol you're using, right? Okay. So let's make a little note there and let's jump into some past papers, right? Right? That's really summarized sent to all, right? I'll see enough. So we're gonna take our time and try to build this one up, right? This is 2022. I said there's not much there. The trick is to really get the inequality, right? There's 2022. Sometimes they do tell you what is X and Y. This one was nice there, and they told you what was X and Y. Sometimes you have to figure it out. Right. So take a little read and then we're gonna do together, right? We're gonna develop the inequalities together and then you have to draw it. Just like form 5. All right, so let's see, right? So in brewery, so a small brewery produces drink A and drink B. To make drink A, you need 5 kilograms of corn, 4 kilograms of hops, 35 kilograms of malt. Right? To make B, 15 grams of corn, 4 grams of hops, 20 grams of malt, but you only have 480 grams of this, 160 of this, 1190 of this. The brewery the brewery makes a profit of 130 for drink A and 230 for drink B. Right, this question was nice there and tell you that X is the amount of drink A and Y represents the amount of drink B. Sometimes they do not tell you that. So my advice when that happens is to start with the objective function. Because you want to maximize profits, right? So you come down here and you can see that the profits is 130 on every drink A and 230 on every drink Y. Right? So it might look like that. That's the objective function. And from that, you might recognize, oh, okay, X could be drink A and Y could be drink B. All right? So sometimes you need to just try to figure out the objective function. But this one, they make it nice, right? So let's see. How we getting the inequality? Let's start with corn. We only have 480 corn, right? So 480, we can't go more than that. Drink A requires 5, right? 5 kilograms. And the drink B requires 15 kilograms, right? So that is your constraint 1. 5x plus 15y must be less than or equal to 48. Next, let's deal with hops. Right? Hops is 4x plus 4y is less than or equal to 106. If you want, you can divide it out. Nothing wrong with dividing it out by 5 or dividing it out by 4. And then with the last one, ox mult. Mult will be 35x plus 20y is less than or equal to 1190. Okay, that's it then. Those are three. Right? Those are your three constraints, and then you have your objective function on it. So what I want you to do now is to draw each one of these. Just like Form 5. Plug in your x and y and then move it out. Sometimes they'll give you a scheme. Hold on. Try that here for now. On the grid provided 1 centimeter to 5 on both axes, you must shade the feasibility region. So where they're pointing, right? So draw arrows for the inequalities and then shade where they all pointed. Take your x, take the coordinates of the vertices and then plug in x and y. Let's see what we get to maximize profit. Right, Jaden? Everybody do it, right? Jaden, Jesse, I'm worried about you. Kieran, Darian, oh gosh, now reach. Darian, do that for me, please. Damian, you too. Try it, please. Draw the inequality and send a picture to me on WhatsApp, please. Pick up as soon as they finish, right? Send them on WhatsApp. Wala yang niya siya. Come on, hurry up. Got your graphs. All right, so Kieran, do a little smart man thing here. Right, might be a little tricky to read all the points, but let's use the cell. Right, hold on, let's three. Right. So Kieran got something like this after he put it into this up, right? Right, nice. So you get something like this, and if you look at it, common region is here. Right? So you have that point there, this point here, this point here, and this point here. So those are your 4 points. Problem is I can't really read it off from there. Hold on, let's make it smaller. Sorry. Right? So your shaded region, and let's do it also so you will see, right? Your common region is here. Right? And of course, you're going to need your vertices. The vertices of that common region will be here, where the x's, right? Here, 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 and here. Right? Those are your common regions. So all you have to do now is just read it off and plug it in, right? But I can't really read it off that scale too good. You have to read it off and plug it into the objective function. Darian said that he got 1228. He got 1228 to be the maximum. That's probably this point here. That point there is probably 1228. After you plug it into the property equation, right? Remember what the property equation was? Property equation was anybody remember? I think it was 130x plus 230y. Was it 130? One 30 and 30. Yeah, okay. And then you plug it in and you're done. Then when I see your graph, red and green points. Yeah, red and green is 1228. Right? But remember, you have to plug it in here. You have to show all of them, right? And see which one is maximum. Yeah. You have to plug in all and see which one is the highest. Darian said he got 1228 to be the highest. Okay? And that's basically it. So all we have to do is practice a few more where the constraints are hard to get. And that's it. Right? That'll be the end of linear program. But if somebody enjoy it, but make sure you remember how to draw it, right? You have to draw it, Jaden. You can draw it, Damian. Trying to make sure I could actually draw it now. Right? Just plug in 2 points and draw it. Okay. Right? Plug in 2 points on the graph, get your lines and connect them up and shape. All were less than, so it's below the line. All right. That's all. Okay, so next week we'll just do a couple of the hard ones and then finish up this topic and then move on again to Hungarian. Okay, module 1 real nice. Once you remember your rules, you're good to go. There's nothing difficult in module 1 and nothing too difficult in module 2. All right, some people might find module 3 tricky, but that's so bad. All right, so nice. That's it there. That's it there.